it was published, it was announced 11 years ago. So it looks like we have smartphones forever, but it's not really that way. And basically, we have to be able to adapt to the market and to delight our customers. And if we go back to 2001 already, so 17 luminaries, including Kent Beck, Martin Fowler, Uncle Bob, so Robert Martin, they gathered together in order to really try to discover and to think about better ways how to deploy and to develop software. And they came up with the Agile Manifesto. The first principle here is already talking about continuous delivery of valuable software. Probably was a bit different from the perception, the conception we have now, but still, 18 actually, we are in 2019, so they had already some rough idea. And actually, what does a project look like, at least from my perspective, what I have seen in the past, let's say, 8-9 years of my career? Like this, it's war. You see smoke, you see gunfire, you see people screaming. And here, you can also see the product owners. So, that's pretty a mess normally.
How many product owners or project managers are here?
Okay, so it's safe to talk.
Okay.
So basically, why? So everyone is kind of, I think you have the feeling, if you have to deploy to production, you get a little bit nervous, I guess. And that's why, for me, the project looks like this. Why? We are basically still more or less using big bang releases, so huge chunks of software deployed twice per year or every 2 months to production. Something is automated, but most of the steps sometimes are automated. They require some kind of heroics, firefighting, and some kind of manual tricks and hacking around. And you see manual testing. That's not our idea. So we have basically here lack of automation. And that's not really great right now. So the world has really changed. Why? In the last 5-6 years, we have seen huge changes in the landscape with the rise of containers, microservices, of course, and container orchestrators in order to manage and deploy containers at scale. And of course, we also see the nice kid in town right here. That's the new, cool, and shiny Jenkins X, which we will try also to probably towards the end to show also a little bit. And let's start a little bit just with a short recap of containers. So we started long time ago with bare metal machines. So on the left-hand side over here. So we basically installed everything on bare metal machines, starting from operating systems, packages, all dependencies to run applications, and it was not really agile. Then we slowly switched to virtual machines, so abstracting the hardware thanks to hypervisors, for example, something coming from VMware or something from Red Hat, I guess, so something like KVM, for example. And still, it was a lot better, but VMs are pretty bulky, so are really heavyweight, and also startup times are not really the best, so it takes still a long time in order to deliver, let's say, a VM to the cloud, compared to the new stuff on the right-hand side here, so containers. So I'm sure most of you guys are, of course, using containers. So containers, what we will see also today, you can just think about containers as processes in the operating system, which are separated. So the virtualization is not anymore at the hardware level, thanks to hypervisors, but it's done inside the operating system's kernel. So you see different processes separated using functionality like C groups, namespaces, and so on. And this innovation has been made really famous by Docker, but containers are actually existing since longer. So Google has been using and deploying containers since more than 10 years, for example. And they allow us to be a bit, let's say, more agile with short startup time. So they're pretty fast, they are lightweight, they should be at least. I think there is still some guy which is trying to containerize a huge monolith, but yeah, it happens. That's not, would be probably, yeah, that's feasible, but probably not really the best and efficient way. Cool. So I think we switch for a while.
So just to better understand, who is deploying containers on production? Better than last time. So we can say 40%. Why? Who is using a container orchestrator to deploy on production, or who is using a container orchestrator on production? 30%. Good. So just to start the core of our presentation, we are speaking about Kubernetes, that is de facto the standard container orchestrator out there. So everybody is speaking about Kubernetes, everybody is using Kubernetes, everybody is studying Kubernetes, and like me, probably nobody is understanding really Kubernetes. Behind the scenes, I mean, I'm studying Kubernetes since a year, and I'm still struggling with the borderline concepts and topics like storage, networking, because I mean, Kubernetes has some interfaces for that, but it really depends on our base infrastructure. So if we are using AWS, the networking is completely different than the implementation of Kubernetes networking in the GCP, for example. Same for the storage. I mean, these are kind of problems that we have to face and we have to keep in mind when we are deploying and using Kubernetes in production. So basically, how is working Kubernetes? Just a brief recap. So we all know that there is one or more master nodes and one or more worker nodes, named also minions. So in the master we have a lot of controllers and processes running. The most important ones are here represented. So the communication point of the master node is the API server. So the API server is distributing our requests, our deployments, our commands to Kubernetes minions, and is the only actor that is actually storing and managing the storage backend, so the ATCD, deployed on the master, and is talking also to the controller manager, to the scheduler that are responsible to manage using the kubelet, that is a process deployed on every minion. So they are responsible to deploy, to manage, to schedule, and to orchestrate all our pods and processes in each single minion. And of course, then here there is something is missing. I don't know if you can figure out. Here we missed really a big important part that is regarding the networking. I don't know if you can figure out. The DNS is kind of, yeah, sure, is involving also the DNS. That is the queue proxy. So we should add something like queue proxy here that is responsible for services, ingresses, and also there is also another kind of controller that should be here, the ingress controller that we can deploy, or we can rely on, for example, Google to have an ingress controller already set up and included. so this is missing. We should add also to this slide this secure proxy. A little bit more in detail, we are communicating to the master, so we are deploying the master through the API server is communicating to each single kubelet of each single minion to deploy our pods, taking care also of the networking services. So the networking services and the data storage services, so the dynamic provisioning of storage if our pods need persistency, actually. And of course there could be many master and many minions. But here is missing something that is really important to abstract our pods that are basically services. So the first citizen of Kubernetes and the most important one for networking Kubernetes are the concept of services that are masking our pods, so how many and which pods we would like to communicate with, using basically a static object.
Lost the control now.
Okay, great.
Spoilers.
Yeah, okay. This is not working anymore. No, this is so here basically we are abstracting, so we are not communicating anymore directly with the pod because as everybody knows, the pod is not supposed to be a long-term process. So the pod could be subject to auto-scaling, horizontally, vertically auto-scaling, and could have errors, could be restarted by Kubernetes. So we cannot rely on the pod and on the IP address of the pod. So we should rely on a fixed IP address, virtual IP address that is given by the services. So this is really important, and this is also the base of each other communication, also using Istio, so the service mesh basically. So here, based on the services, so really speaking about networking, we see some fallacies of our distributed architecture and distributed computing. So here, basically, we can see that here, ideally, we have a service A and a service B, and they are communicating. So here we have the communication between the two services, and ideally is, in our mind, is working like this. Is A is communicating with B, but actually there is the networking in the middle. So we can say everything in the middle. I mean, we are speaking about hardware, software, virtualization, virtual networks, whatever. So we cannot have anymore this kind of dream. We have to face the real world. And in the real world, there are some different paths and some difficulties. So for example, the networking could be really slow. So we have latency, bandwidth limitations, and so on and so forth. I mean, also we can lose some packets during our trip from A to B, and so on and so forth. So this is not really reliable again. And this is also introducing new challenges that are, for example, timeouts. Then we should take care of if we hit a timeout for any kind of reason, we should also manage a retry, because there is not one shot. We could also implement some retries. Then, based on how many retries we are accepting, we should take care of circuit breaking. So if the service is not, if our service is not healthy anymore, we should give it time to recover. So it's completely useless to continue sending packets and requests and packets to the service, because it is not serving anything else. So we need time to recover and to get back our service. there is also rate limiting, so we need time also to horizontally auto-scale pods, so passing from 2 instances of the pod to 20 because we need it, but it takes time to speed up pods, even if our application is really fast. And then there is also another one, scaling from 2 to 20 pods, we have the problem of load balancing, round robin, different kind of policies that we should know, we should study, we should test, and we should take care in our infrastructure. And this is really a huge amount of work, not only for DevOps on the DevOps side, but also on the development side, because the first thing that was introduced a couple of years ago, or some years ago, from Netflix, and then adopted also by for example, Spring Framework, Spring Cloud, Spring Boot, are some kind of code solutions for these problems. So implementing, for example, Eureka for service discovery in order to rely on service and DNS, so service name instead of IP addresses, more flexible. Then rely on Istio for our circuit breaking. Then rely on Ribbon for client-side load balancing. And then also Feign to mask our communication between services and to be more flexible and more let's say, fast to develop. And then Zool with the API gateway and another bunch of problems, so synchronizing requests, cascading, and so on and so forth. This is pretty good. This is a really good approach, but has some drawbacks. And these drawbacks are really simple. Every of this solution is code-based. So our developers should take care of everything. And on the DevOps side, there are other challenges, less, so the balance is not really in the middle. So we are focusing just on development, so the development time is really, really slowed down, and it takes long also to test, because every single component we have to test in our solution, because yeah, it works ideally, but it's not something that we could rely on in our system, for example.
And what if we are not using Spring Boot?
But this is another question. I suppose that everyone here is working with Spring Boot or Spring Cloud or Spring Framework. Yeah, good enough. What about Golang? What about JavaScript? What about my friend Robert that is working with Java, EE, and other cool stuff? I mean, we should rely on something that is not code-based, because it's too difficult to manage, it's too slow to develop, and is affecting just development. So we can share the complexity between development and DevOps. And in this case, we should abstract this kind of functionalities so we can apply to every kind of services, not only Java services, Java-based, but also Golang, whatever, JavaScript or whatever. And what is the solution? This kind of new silver bullet just right after to Kubernetes is the service mesh. So who knows the concept of service mesh? 50%, nice. About service mesh, I'm speaking generally, not about Istio. We will see Istio later. So the service mesh itself is kind of simple. The concept is kind of simple. We should separate everything that is related to networking, so timeouts, retries, circuit breaking, load balancing, and everything, from our service, taking out to another service. In this case is a sidecar proxy, is named like this. So we have a data plane that is including our services and our sidecar, and there is this control plane, this really cool stuff that is kind of, we can see like a watchtower, is working for us, is automating everything for us, in order to avoid to implement everything in our service. So here we are taking out the complexity from the code, because the code should be focused just on business value, delivering business value, like told before by Paolo from Agile Manifesto. So we should take care of this. We are developing business value. We know that it's really important, sidecar proxies, service mesh, everything on the infrastructure. But infrastructure doesn't make really business value in really a business way. So something, the service, if the service is not working, the infrastructure is useless. If the service is working but the infrastructure is a mess, it's useless the same. So they share a common focus, that is delivering business value, but we should really share the complexity between among different actors, so the services, the sidecars, and our control plane. Of course, we have to take care of everything using using monitoring, logging, and tracing, so we can still have an observable architecture, an observable group of services, because something that is not observable in the cloud native, honestly speaking, doesn't exist. So if we have some black boxes here, we are not able to understand how they interact, how they are working, they are useless. We don't understand, we cannot debug, we cannot understand what's going on, and so on, and so on and so forth. So, which is the best, which is the most cool actor on the service mesh scene right now is this Istio, that just 8 to 10 months ago went general available.
Looks like Google is winning everything.
Yeah, more or less. I mean, this is coming also from Google and IBM, if I remember well. So it's a joint venture between these two big companies. So like Kubernetes is a really big joint venture between big companies. And the problem is service mesh concept is really easy. Istio is not easy. Istio is I mean, we can read, we can figure out what's going on, a lot of components, so what is for sure that what is really understandable is there is some different services and some proxies. The rest here in the middle, there are a lot of questions, open questions on what is doing Galley, what is doing Pilot, what is doing Mixer, Citadel, what does it mean adapter, how they are distributing policies, what about mutual TLS or TLS certificates, how to take out configuration from our infrastructure. In this case, our infrastructure is Kubernetes, but could be Cloud Foundry, could be OpenShift, could be also bare metal. Why not? Depends. So here, and then, of course, everything around there is the observability. So we have Prometheus for metrics together with Grafana, because honestly speaking, the UI of Prometheus is not okay, just personally. Then we have tracing, and then we have also some kind of map of our service that is done by Kiali. Istio is not including logging, but this is also relying on us. Google is not able to do everything. So, but yeah, okay. We should add here both also logging, like Elkstack, Graylog, whatever, to complete our 3 pillars, cognitive pillars. So let's dive a bit into Istio. What is Istio? It's a service mesh. Yeah, great. How it's working. First, most important component of Istio is the sidecar proxy. Istio is using Envoy proxy as an extended and really strong battlefield version of Envoy as sidecar proxy, so we can rely on Envoy for every kind of communication between services. Okay, how to configure our proxies? Our proxies are configured by Pilot and by Mixer. Mixer is a really big player in Istio and is managing the policies, so is granting that all policies that we wanted in our service mesh is distributed to sidecars and is respected. So the sidecar is connected constantly with the mixer to communicate, to have a look at policies. So what should I do? How should I communicate with other services? In which way, TLS, and so on and so forth. And communicating also the telemetry, so respecting the observability. Mixer is using this telemetry to distribute data to adapters. Here we can say that here there is Prometheus, so Open Matrix adapter, and here there is the Open Tracing adapter. So the adapters are just something that are used by Mixer to distribute observability to our, let's say, satellite tools. Another really important, who is really managing Istio? Pilot. Pilot is doing everything. Is doing really everything. So he's distributing configuration to Mixer and to sidecar proxies. Is configuring everything. So basically, we are communicating to Kubernetes, and Pilot is managing everything. But how? We are communicating to Kubernetes. We are not directly communicating with Istio. So how can Pilot know about configurations? There is Galley. Galley is the edge of Istio that is responsible to communicate, to take out configurations and our to take out configuration from our infrastructure, our platform. So, for example, from Kubernetes, and is translating into Istio rules. So, translating from what we would like to have into policies to be distributed to the mixer, of course, managed by the Pilot. And then there is our beloved security that is managed by Citadel, and together with Pilot. Pilot is everywhere. Apart from telemetry, Pilot is doing everything. The telemetry is just here in the mixer. Citadel is the guy to issue and to get TLS certificates and to distribute these certificates to our proxies. This is just an overview. If you would like, Istio.io is really a good wiki and a good starting point to install, to have a look, and to study. Honestly speaking, I was reading the documentation. It took 2 hours to understand what the fuck is doing Pilot. So, and Mixer is not so easy also as well. But let's go farther.
You didn't tell me it was so complicated. I think I'm going to the other workshop.
We started to figure out how to use Istio, and okay, let's do a presentation. Then we studied really deeply the documentation of Istio, and what the fuck? The bad idea was the presentation on Istio.
Yeah. Just short recap for the next topic. So the advanced deployment strategies. That's also the main, let's say, focus of now. Shortly, the hands-on session. So we have, for example, a couple of services. So 2 microservices. We just deploy them to Kubernetes. Istio is injecting the Envoy proxy. Then we will basically just upload some configuration. So the Pilot is gonna basically just configure the Envoy proxies. So, this is how we will achieve the advanced deployment strategies. So, one is the blue-green deployment. So, let's suppose, for example, we have version A and version B. Version A, for example, is the old version of an application. Let's say version 1.0. And then we have version 2.0. We deploy them alongside. They can be, for example, both production environments, but some people is even using production and staging to perform this trick. And then there is an intelligent load balancer. Whenever a CI server, for example, we shouldn't do that manually. It's saying now we switch from version 1 to version 2, and we basically reroute the traffic instantaneously, almost. Should be almost, let's say, without downtime. And we keep the other version still running in case there is an issue. We can go back to the version 1, for example. So here we can see, for example, production, version 1.0. Traffic is going from your browser to the old version. And then we see after the switch. So now we are routing to the blue, to the version 2.0. And it's pretty cool because with this technology, just with a little bit of automation in our CI server, for example, Jenkins or Jenkins X, we can basically achieve zero downtime deployments and also rollback. The hard stuff normally is done here, actually. It's the data. Then we have second strategy, the canary deployment. That's, for example, the big players have been doing this for a long time, like Facebook, for example. So you can just route traffic through an intelligent router to, let's say, 98% is going to up here to the old version. And then we say, imagine if Facebook, for example, released something, or Netflix, and they screw up. They would make millions of people, or a lot of people anyway, pretty upset. So the strategy is to deliver the application just to a subset of the users, monitor the results through analytics and through our, let's say, also Prometheus Grafana tools. And then we have to check, is something bad happening? Yes, no. If something, or if some users start calling, start sending emails, tweeting about, oh, your website sucks, so maybe we can switch again the traffic to the blue one, for example, to 100% here. If we are successful, we can slowly increase the percentage here, which is routed to the new version. And this is also a good, let's say, performance test. There is also another possibility. We could also do some intelligent routing, not just based, let's say, on some kind of round robin or random rules, but we could even inspect, for example, HTTP headers. So we say, for example, just the users with the iPhone or just the users using Google Chrome will see the new version. Maybe the other guys with Safari or with Android phones will see the other one. So it's really pretty flexible. You could even use geographic deployments. So just the users in Switzerland will see the new versions, while the users in the US will see, for example, the old one. That's pretty handy. Okay, so now we will show you just short.
Just for sake of completeness, we can. Who is deploying, for example, blue-green deployment? Who is using blue-green deployment or canary deployment in production?
Right. Okay, so we can see it.
Just please follow us in the next presentation, please, because we need you.
Okay.
Yes.
So the demo architecture. We have a really simple example which we can discuss and we can show to you. We have, so it's based on the example which has been produced by Ray Zhang from Google, and we were inspired also by his code and, well, by his workshop. So we have at the really top here, we have a really simple microservice. It's a guestbook UI. which provides us a user interface and a few endpoints to call. Session information is stored in Redis using Spring Data Redis and Spring Session. Then we have a guestbook service, which is just basically saving our messages in a MySQL database, super simple deployment in Kubernetes. We know that stateful workloads are tricky. Then we have a super simple microservice, which you just say, hey, I'm Paolo, and he says back, hello, Paolo. So nothing, no rocket science. That's the demo architecture. Now, hopefully the demo gods are with us. Let's try. Ah, yeah.
If you want, we can make 5 minutes pause because we were boring with these slides, but we are making more interesting things later. So if you want to have 5 minutes pause, or we can continue after it.
So who wants to make a break?
What? No, it's majority told no. So let's continue.
Okay.
We finish earlier then.
Yeah, I mean,
5 minutes earlier. So
it's pretty. I mean, I don't think we will gonna use the 2 hours and a half, but it's also open. We are open also to. I would say we can reserve some time to discuss openly our ideas.
And we would like, if it's not a problem for you, we would like to receive a feedback on our presentation/workshop. We would conduct and present less and be more interactive. But we tried 2 hours and a half, 3 hours with RaidSang on Istio, and it's not possible. No, I mean you need at least, if you don't know Istio, and that's the reason why probably the majority of you is here. You need more than 3 hours if you want to understand something and not just copy paste from the doc to the CLI. So that's why we organize something like this that is interactive, and we would like to go further with commands, and we will ask you what we should expect from each command, what's happening behind the scene, and we will show you.
Okay. So if you want to take a picture here, you can get this Google Doc to try that really calm and really comfortable at home, and you have also the Git repo here, which you can check out either now if you're, let's say, if the Wi-Fi is stable, and if you wish.
In the repo there is the we showed you that one of the services should be written in Go. Actually, we are not really Go developers, so we tried. We were not able really to achieve our goals, so we preferred to show the whole Java version. But we are working on it.
Let's be honest, we were in vacation.
How was it?
No,
just to let you know, because in the repo there is the Java Spring version. Honestly, because my code in Go is still.
You don't want to see that.
No.
Okay. So this is the document. So if you just click here, you will land on our super simple code base. Now let's start seeing what we installed. We are using the Google Cloud Platform at the moment because we believe right now Google Kubernetes Engine is the best offering for managed Kubernetes. So you have others out there from, of course, Amazon, Microsoft, but this is the best performing one, and the most stable. So you can see a bunch of tools already. This, so we can filter by namespace. for example.
That's also one service.
We have 3 services and 2 persistent, let's say, applications. So this is the Istio system.
Just to let you know, I mean, we are speaking about Istio, and Istio makes sense for a certain kind of architecture. For this sample, I mean, we are speaking about some play.
Yeah, of course.
Yeah, so it doesn't make sense for three services. If you have 3,000 services, it makes a lot of sense.
So that's exactly so. You anticipated actually.
So
we have a few slides. We have back. We could even show them right now. So
no, don't worry.
Istio is an awesome project, but use it if you really need it. So start now for the sake of the demo, it's okay. But I mean, start slow also because Kubernetes is really difficult, and so also the patterns we have to embrace are not that easy. The biggest challenge is actually not a technological challenge normally, but a human challenge. So also the learning curve, the willingness of the people to learn. I mean, we are experiencing that by customers, so it's not that easy. And of course, not use Istio because you saw that at some conference or talk.
not this one.
So
this from Google, not ours.
So ours is a lot better, of course. Okay, so as Matteo introduced, we can see a lot of components. Maybe could even zoom a little bit. Yeah. So we see Grafana, starting from the really top. We can see Grafana, we can see Citadel for security. It even clicks. So we can see Galley for the configuration. We can see the ingress gateway in order to route traffic inside the cluster. We can see the pilot, so the big guy. And as you can see, we have 2 replicas running. So we can see a sidecar injector, because as we said, we have a microservice, but every microservice to be in the service mesh needs a proxy. And every time you deploy an application, the injector is gonna inject basically the envoy proxy. We have the telemetry and the tracing part, which would be basically what we showed as the mixer.
Together with these 2 points.
Exactly. And then the last 2 guys, but not the least, we have Prometheus for metrics collecting, and Chiali. It's a pretty new, shiny product. I like it. We will show it to you. It's just for visualizing the services, because otherwise it's really some kind of hard to really have a mental picture of the services. In our case, we have just 3 microservices. It's not that difficult, but imagine if you have 500 or this kind of order of magnitude. So we can go to the console. I hope you can see, guys. So
probably you can show the other services.
So now, guys, can you see in the back? Let's make it a little bit bigger. The funny part is that in my laptop is already huge. Okay, so we said we deployed the demo application. So this is in the default Kubernetes namespace. We can see the guestbook service. We can see the guestbook. Actually, I can even zoom like this. We can see the guestbook UI. So, and we have 2 replicas. So as you can see, guestbook service V1. So we have 2. Guestbook UI, same stuff. We have the Hello World service. We have 1 MySQL and 1 Redis. So this is the application. Did I miss anything? Okay. So, do you know, guys, what what it means. This guy here.
Containers. Put all sidecar.
So, for example, we can get the guest to the pod, whatever. We can get this one. Okay, so you were right. It's a bunch of stuff. And here, actually, we can do this. Okay, we see the first container. So it's the application itself. It's the guest book service 1.0, first container deployed. And then we have this guy here. So this is Envoy. So this is the proxy, which has been dynamically injected as soon as we deployed the service. And this is done just if you tag the namespace to be with automatic injection.
I don't trust you, so let me show.
I never lie.
Show me the tag.
So we can get the namespaces. As you can see, this is the Istio system namespace, where Istio is installed, the classic Kubernetes namespaces, and the default namespace where we deployed the applications. And let's describe the namespace. The default one. Here, we can see the Istio injection is enabled. So we needed to tag it. If you don't do that, there is no injection. So you have to inject it manually. And of course, why should we do that manually? We want automation, right? Cool. Any questions here? I think then it's okay. We can try to start. So we have seen the pods in the Istio namespace. Now we have seen the pods which are basically making up our application. We have seen the description of one application in order to show the sidecar container injection. And now we talked about deployment strategies. So blue-green, as you remember, and canary deployment. And now we will try slowly, we will try to achieve that.
Actually, Paolo, we missed to discuss about ingress gateway and egress gateway.
Yeah, so let's start doing that. So it's faster. Never do copy paste. So basically, as you can see, in the Istio system namespace, we have a really special service, which is of type load balancer. Do you know what does it mean? So let's recap. You have different type of Kubernetes services. So you can expose an internal IP address, case number 1, which is reachable just inside the cluster. You can expose that by exposing a port on every node which makes up the Kubernetes cluster. This is a node port. And then you have the load balancer, which actually relies on an external L4, L7, depends on your configuration, load balancer. And as you can see here, we have the load balancer as an internal IP address, just valid for the Kubernetes cluster, and an external IP address, which has been allocated by the cloud provider for us. So in our case, since we are using the Google Cloud Platform, we can just jump here into load balancing, and you see a bunch of load balancer. Unfortunately, they don't give really meaningful names when they are creating it, but you can see we are not cheating. So the DevOps stays Istio, so it's the defined backend for this load balancer. So all the traffic reaching this IP address is going to be routed to the Kubernetes cluster.
Let's make it more interactive. If you want, you can
Yeah.
grab your mobile phone. If you have the Wi-Fi, and this password is written here. Please go to this external IP address and guess what's happening.
So
we just installed Istio
and nothing else.
and nothing else, just our services, and we were not configuring anything else. So what should happen right now if we hit this IP address?
On which port? Just 80. So
Okay,
not
just 80. Just a normal IP address,
IP,
like a normal web page, let's say. You forgot?
to open the port.
This is not true. The port is open,
You are pretty close.
but you are not so far. Yeah.
Inbound is not
This is not true. The same. No, the inbound is allowed because Istio ingress gateway is letting us to receive traffic. Actually, it's something related to Istio itself. In order to communicate with our service mesh, with our services internally, we should define some destination rules in order to let the ingress gateway understand where to route the traffic. So in this case, the ingress gateway is receiving the traffic and is answering like, I don't know what should I do. So is accepting the traffic, but Istio doesn't know where to route the traffic. So we should instrument Istio to route the traffic to our guest book UI.
I think you got an error, right? But do we know what we are doing here?
I'm not here. I'm just
We need some help.
3D printing.
Okay. Yeah. Okay, guys. So we just try to. We have an external IP address after just installing bare bone vanilla Istio, no configuration at all, and as expected, we have a connection failure. There is no configuration. So we have to start configuring now, sending our configuration through Galley basically to the pilot, and starting configuring the system so that we can allow traffic to reach the cluster.
Actually, not to reach the cluster, but to reach our service.
Exactly.
Inside the cluster. Because
That's
the cluster
more-
is already reachable.
That's more specific. That's better. Okay, so this is the folder for
So
our.
this IP address is it's load balancer or what is
The address is given by the Google Cloud Platform based on the load balancer and firewall rules and so on and so forth. There are 5 to 7 different guys inside the load balancing, ingress controller, ingress gateway of Istio, and so on and so forth.
You can see, so it's basically we are talking about an L4, so TCP load balancer, 34, 65, whatever, and that's exactly the IP address we see over here. So let's recap. We have a Kubernetes cluster. We installed Istio on it. Now Istio contains an ingress gateway, as we see at the really top here. And we have an assigned IP address by our cloud provider. It's a little bit more tricky if you are managing a Kubernetes cluster by your own. You have to provide, of course, the load balancer or a proxy in order to reach it.
This is of course different in AWS because the networking is managed differently. So we are speaking about Istio and not on GCP. So ingress gateway is specific by Istio, is a CDR of Kubernetes. So it's not Kubernetes is not related to the GCP, it's not related, it's just related to Istio itself.
Mm-hmm. So am I allowed to do copy paste one more time?
No.
And then just manual
You
stuff.
ask me permission.
Okay, so first of all, we try to configure the ingress gateway with a gateway definition. Let's have a look at this guy here. Okay, this is our, we don't need it anymore. This is our microservice application, Istio rules, the gateway. So here, as you can see, probably you recognize it's a Kubernetes CRD, so for Istio. And here we are defining a gateway with the name guestbook gateway, which is using the mentioned before Istio ingress gateway. And you can use, of course, virtual hosting. In this case, we just use every domain. Doesn't really matter. But you can actually have more domains. And we specify which type of traffic we want to basically to route to our services. So at the moment, we just want HTTP traffic on port 80. And that's what I deployed.
So now should work or should not?
So
It's empty.
It works, but it's empty, right? So you get
but it was
you
not
guess
supposed to happen, right?
what? Working and
Should work.
empty should work. I don't know.
Probably
We should ask. We should ask.
probably
Because probably there are more experienced people.
See?
404 not found.
So
You get to 404
Ah.
not found. So there's
Okay.
no resource definition in the back.
I think it's better if you go to the other workshop.
yeah. Or please join us to present because we need.
Okay.
We need,
So we get a 404. Yeah. Why? So basically now we configure the gateway. So the traffic can reach the cluster, so through the ingress gateway, but then the ingress gateway doesn't know what I have to do with this stuff. So we just get a standard response. So this traffic is reaching the Kubernetes cluster. As you can see, we get something, but it's still an error page because it's not bound to our microservice architecture yet. So we have to do that right now. Okay. I said no copy paste. Almost. Okay, so now what we need is a virtual service. So let's deploy the virtual service. And while it's taking, okay, this is what I just deployed, a virtual service. So also an Istio custom resource definition for Kubernetes. What's interesting to see here, basically, is the last part here. What are we doing? We are trying to say how we want to route the traffic coming from the Istio ingress to our microservice architecture. So basically, when we uploaded this file, the pilot picked up this configuration and started configuring the envoy proxies. And now here, so traffic coming from the gateway, guestbook gateway, and that's what we defined here. As you remember, guestbook gateway. So all traffic coming from the guestbook gateway with this prefix matching this URL is going to be routed to this microservice, guestbook UI. Guestbook UI, of course, is a Kubernetes service. So if we go to the definition of our Kubernetes deployment for our demo architecture, we can see the guestbook UI. It's a plain, simple Kubernetes service. So, did you try already?
Please generate some traffic, otherwise we are not able to show you anything else. So what's happening?
It shouldn't happen hour, but yeah, 1 second, because I don't have the environment variable here. Yeah. Whoa, whoa, whoa. So it's a nice UI, right? So super innovative. So I think that's the best UI I can write.
We should involve and hire a front-end
Yeah,
developer for us.
we need front-end developers, guys. Okay.
Error.
Error? No. Hopefully not. Ah, no injection, no attacks. By the way, it's not secure. It's not secure.
Okay, we have an issue. He's trying to greet and to send a message, and he's not able. Ah, yeah. I love these issues.
But yeah, I mean, at least we have a few messages.
Someone is doing probably you were not.
I mean, we didn't actually try with this kind of work. Istio rock is complicated. Yeah, a bit. Call me. Ah.
Call me. Please do not SQL injection, because we are not security guys. Exactly. I got you.
No, don't screw up our workshop. No injection. So this looks like a, you know, the public toilets when you see something like that. Cool. So I'll also send a message. Istio. It's too complicated. Oh, it works. So as you can see, so we can send a message. All these messages are basically saved into a MySQL database through the guestbook service. The guestbook UI, well, it's in front of you. And we said we have an hello world service. This is wow. So awesome. This is coming from the hello world service.
Oh, we
So,
found the issue of this guy.
What was the problem?
He was cheating us. He was using a VPN. The VPN restricting posts. No, this is not fair.
Do you work for SAP?
Probably not.
No.
I mean, that's not the root cause. We cannot be certain of that because I can't post in other websites. So there is an issue. I turned out to be enough. Okay, now it works, but the root cause is not necessarily
Sure.
me. It's
No, should not.
The root cause is that firewall blocks you accessing an IP.
Could be,
Yeah.
could be not your VPN,
But
but
then
the
I
firewall
would-
behind the VPN.
But
that is
then I
blocking
wouldn't see the web
posts.
page. I'm seeing the web page.
No.
Yeah.
No, it could be more complex,
Oh, okay.
and you can restrict posts or puts and so on, but allow get. So it depends. Depends on your firewall.
Yeah.
Sorry.
No problem. So it's the purpose also, I mean, of being a bit interactive.
But I seem to be on the website.
So let's recap a bit, just a bit what we did right now. What we did is just to configure. No.
UI.
But it's better the slide of Istio.
It's not working.
Yeah.
Stop working.
Ah.
Yeah, you killed
Who did SQL injection?
Instead of publishing, So you go down, you don't see Paolo.
Hopefully.
Really?
Go Put
Go down.
the list
No,
is
that work.
Oh,
Ah,
nice.
says Paolo.
nice.
This is a good point for our observability. Let's say observable microprofile.io.
I know
Now
this
you
Thank
guy.
you, Robert.
Now you can show us how to do disaster recovery of database on Kubernetes.
Yes, you can wait after our presentation and we can speak about it. We will see. Just to let you know. So what we did is just we submitted, we deployed
Here, or-
some. No, the Istio was like the second. Okay, good. And just to let you know, we deployed our configurations to basically Kubernetes. So these configurations are taken by Galley, are communicated to Pilot. Pilot is understanding this configuration that are not anymore Kubernetes configuration, but Istio configuration. So they were translated by Galley. These configurations are distributed not only to Pilot but also to Mixer, because Pilot is distributing this destination rules and policies and so on to proxies, but Mixer has to ensure that these policies are respected. So the proxies are communicating to the Mixer, and the Mixer is saying, yes, you can, no, you can't, based on the policies. With this communication is taking a bit of time, but there is cache, there are methods, and the whole bench of communication is slowing down. The whole bench of architecture is slowing down the communication. Supposed to be around 8 milliseconds per request, with kind of 1,000 requests per second. So really, in the worst case of this, should be acceptable right now. So they are speaking about, with more traffic, they are speaking about 10 to 20% of delay, of increasing latency, because of the service has to communicate with the proxy has to communicate with the other proxy. Before that, the proxy is checking about policies with the Mixer, cache, and so on. And then the Mixer has to decide if you can, you can't, and so on. So this is basically what's going on behind the scene. Everything is registered with telemetry and observability for Prometheus, Grafana, and other things. So this is basically what happened behind the scene to these rules. And this is valid for all these rules that we are going to deploy on, that we are going to use on Istio. So it doesn't matter if it's gateway or virtual service or destination rules or whatever.
Cool. Okay, so let's try to simulate some faults, because what I have seen right now and what I have been doing also normally, so we just we code, we deploy that, and we hope for the best. And then, I mean, we are kind of surprised when something doesn't work properly. So I think we must be more cynical. We must be really aggressive while testing. We should really assume the worst, and that's the only way actually we can achieve resilience. That's why, for example, you don't see companies like Netflix with huge, let's say, outages, because they are really focused on chaos engineering. So they simulate, they inject failure. And now let's try to inject something. Even though it's a really rudimentary architecture, we can basically inject some failure.
It already failed.
It did. I think it might be something related with pagination.
No, the problem is
If we have time later, we log in MySQL, we perform a query, and we check how many messages we have.
the problem is someone injected an HTML tag, I guess, and if you look at the source of the web data, I guess the messages out there are not displayed.
I said no injection attack.
But it ends with H1, I guess someone was.
Might be. Yeah. I didn't. You see, so we were not cynical testing. You see, so for example, for the sake of the demo, it might be okay, but this stuff is really happening. So it's not really the best. So we should be more, let's say, we should, let's say, work in a way so that our applications are resilient. And let's inject another failure. So now what I'm injecting, you can basically simulate an outage. So what I'm using now is I'm overriding the virtual service I defined. So here, yeah.
It's the HTML rendered on the server.
It's rendered in the guestbook UI.
It's on the server.
Yes. So it's really, we are using Spring Boot with a time leaf. So it's here. So we can either go directly to the POM in the dependencies, and you can see here time leaf. And the resource is just super simple web page. Okay, guys, please. Yeah. So, get virtual service. Oh, that's kind of crazy, but so this is the active configuration. At the moment, I don't know exactly why.
Maybe the percentage is from 0 to 1, not from 1 to 1. I don't know.
Because we had 100 before.
You mean 0.5? Should not be like this because it should be 0 to 100.
We have to check in the
Let's try.
documentation. This is weird.
That's right. You can try, Paolo. Try to 0.5.
Why not?
Just to.
That's why it's called.
That's why it's called percent instead of
Yeah.
another name that I don't.
Can be anything.
Let's see.
It looked like you were landing on the different instances of the service when you refreshed your page.
This is pretty normal because there is instead of rely on pods, we are relying on the service.
Yeah.
Kubernetes service. Kubernetes service is making round robin, so it doesn't matter.
That's a good
Istio
observation.
is in the middle. The sidecar is communicating to Mixer. Mixer is denying the communication. This is why Mixer is in the middle as check policies.
Yeah. So we have something similar basically.
Yeah.
For the hello world, we have two replicas. As you can see, so if we check, let's go to another tab. This was another stuff. So kubectl get pods, a bit bigger. As you can see, the hello world service, probably you were referring to the message. So if you check, one is going by round robin, so to the first, to the second, but this is just default Kubernetes. Here we didn't define a virtual service, at least not yet. Because if you don't define anything, just standard Kubernetes stuff.
Have you applied the rules?
Okay, now, so let's try with the 0.5. It can kind of blow up. Yeah.
So it's not 0.5, this is 0 to 100.
Yeah. Crazy, but we will try it in the.
Let's move forward
Yeah.
a bit because we have a lot of different percentage to show, so we can better understand if we are doing a mistake or if we are missing some configuration that could happen.
Okay, so now the last part I will be carrying out before Matteo takes over. We said blue-green canary deployment. So we will perform a blue-green deployment and a canary deployment. So we will basically now we are routing, let's say, to the guestbook microservice application version 1, at least the UI, and then we will switch to the version 2. So we have to deploy a version 2 to Kubernetes first, and then for the canary deployments, we will switch part of the traffic to version 1 and part to version 2, and also using HTTP headers.
How many of you have an iPhone? Wow, nice, great. So with the iPhone, we can try also to route differently for the iPhones.
If we have the right regex,
I rely on you.
I hate regex.
Don't answer me with the 500.
Otherwise, you know, I mean, Stack Overflow, copy paste. That's what we do. Okay, so now in order
It's
to
evil-driven development.
Okay, so now we said we want to deploy version 2, so we have to apply the manifest.
Have you removed this 500?
It's a good point. Let's try to refresh. Not yet. It's good to have, you know, pair programming.
And what you did?
It's almost mod programming here. Istio, what's the name of the folder? Ah, okay, I'm already.
It's Kubernetes.
I have to delete the Istio rules, the number 3. Ooh.
As you can see, it takes just
Just
really few seconds because you know Kubernetes, Galley, Pilot, Mixer, proxies. So it's really long trip.
Okay,
But
so
still, we're speaking still about 2, 3, 4 seconds.
we have the Kubernetes v2. No? And here. So we have the second application. So we have the user interface, same stuff. We will change just the color, the background. So this is the version 2, and this is a Kubernetes deployment. We have the service as well. Where is it? We have to check if. So I think it contains also the service.
No, there is no service.
Ah, yeah. Great. So it's done. So now, if we get the pods, we will see also the version 2 running. Hopefully really soon.
Actually, why here is tricky, Kubernetes is a little bit tricky because here is the pod is marked as running, but we have just one container that is running. Guess which one is running so fast?
Yeah.
But this is kind of a problem because if Envoy, if the sidecar proxy is running, the pod is marked as running. So it's not really fair it will be shown.
But from an order, the envoy is started first.
Yeah.
For
So
the order, it doesn't matter if it's started first or not because Envoy is so fast, the startup of Envoy is so fast that
Okay, but there could be an window of opportunity for unprotected services.
no, because the service is not reachable.
Depend on how the health checks and find the fraud like readiness and blindness. Find the fraud from
Yes, right. We should fine tune that part, liveness and readiness frauds, in order to get better observability in this case. So instead of getting running, we should get still startup or container initialization in order to better understand what's going on.
Cool. So basically, it's a Spring Boot application running in a Docker container with limited resources, so it takes a while to start. Envoy is crazy fast compared to Spring Boot. Yes, especially
Defining the readiness probe.
for the
The readiness probe, is this defined by Istio? Or is this just the definition you have for your pod?
No, the readiness probe relies on, in this case, there is a Spring Boot actuator that is exposing metrics to Prometheus, and there is a Spring Cloud, that is exposing metrics to Prometheus. We don't need Spring Cloud Sleuth, because for the telemetry we rely on Istio. The actuator actually is exposing metrics, but they are not used. They are exposing their actuator is used just to expose health and info endpoints in order to understand liveness and readiness probes. So you can fine tune, and actually the Istio documentation advises to not to rely on this kind of code APIs or REST APIs or whatever, but rely on something more related to the process, to the internal process in the pod.
So if I explicitly define my health check in my pod definition or
Yes,
pod
yes,
definition,
you can.
this will go through or will it be modified by Istio?
No, this will go through because this is not Istio related. This is Kubernetes related. So,
okay. And nevertheless, it could be touched by Istio as well and modified to be rerouted to Envoy or whatever.
Liveness and readiness probe, you don't need actually, because this is just for Kubernetes. Liveness and readiness probe is.
So this remains untouched by Istio.
Yes, yes, actually yes, or you can. Yeah, actually yes, remain untouched because Kubernetes is accessing the pod and is communicating with the pod and with the container inside the pod. So you can define two different liveness probes, or just one that is concatenating the check of Envoy and the check of your service.
Basically, you have to, because mainly if I define my health check going to the application, now I have Istio deploying the proxy in front of it, and then it's misleading. It's as well it's running while it's not, because maybe Envoy has a problem. So it could also be that Istio is modifying it by saying, well, I make sure that this is true and the proxy is running as well. So,
yeah, it should be like this, and you should. That's why Istio team is advising to modify the liveness from an endpoint to internal container processes.
But how much time do we have left?
So it's
45 minutes.
8. What?
It should be
Not that far.
half past 5.
Okay, well, let's see. Okay, just to answer your question.
Yeah, but is an interact. I mean, this would be better to interact with you on the laptop. We tried. No, it's not possible. I mean, someone is using Windows, someone is using Linux, someone Mac, and so on and so forth. There are a bunch of problems that we already faced, and in 8 hours we were trying to achieve something with about Jenkins X CI/CD pipeline and so on with Istio. 2 hours and now it's not enough.
Okay,
For a really full interactive presentation and workshop.
Yeah, just to get back to you, so Guestbo UI, we have a Kubernetes deployment, and normally you specify the readiness and liveness probes. So this here, so standard Kubernetes stuff. So it's basically pinging the actuator health endpoint.
In this case, basically, Istio is letting us
just
access to these two endpoints, so we don't need to change it. It's the best practice says that we should change it to include Envoy, so we can have, instead of running when Envoy container is running, we should get container initializing because the service is not ready yet. So we should fine tune that part. So this is up to you. I mean, this is just an example, and it depends on your application. Let's see if it's Java, Golang, whatever.
Okay, so let's try now to finish this part. So okay, so now let's do the blue-green deployment. So we have to define a so-called Istio destination rule. And what's important here is just we define two subsets, V1, V2. And we filter by label. So each pod has labels, and we have the pod with the label version 1 will be in the subset 1, and the same for version 2. So let's deploy the number 4. So where am I? Okay.
Meanwhile, which is the difference, mind about the difference between destination role and virtual service. We are not defining a new virtual service. We are communicating with the same service. We are
not yet.
Okay. We are defining a new destination role. So we are communicating with the same Kubernetes service, but we are routing to different pods. Actually, that's why we deployed the version 2 just as Kubernetes deployment, no Kubernetes service. So this is also another level of abstraction of Istio, even passed by Istio, in order to fine-tune even more our configuration and our tests and our possibility to play with our configuration and with our networking.
So as you can see here, we didn't deploy yet the definition for the blue-green deployment. This is just standard Kubernetes routing, so the service, which is just load balancing with a round-robin technique to the guest book UI V1 and V2. So green, white, green, white. So it's a bit slow now. So this is this pattern, basically. So let's deploy just for the version 1. So basically, the starting point. So now we want the traffic, so old version. So we just want the traffic to go to the old version. So it's our starting point. We shouldn't see any green, hopefully.
Please check on your mobile if everyone has white background. If there is a green,
so we are to the blue deployment. And now we will switch if everything is fine.
Someone green, someone
clean your cache.
500, 404, whatever. I mean, personally, my mobile is not working, so I can't test.
Cool. So
Great.
now we are ready. We deploy, so basically this definition. Now the load balancer is switching to the new version, to the version 2. Version 1 is still running, but is hidden, is not reachable, is no traffic is routed to.
So please refresh, and if someone is white, join me here in the shade part.
Yeah. So now it should be just, now we are routing just to the version 2. And actually we can, later Matteo will show that also what's happening, because we can monitor this stuff with Grafana and primitives. Okay.
Now we are speaking about what's happening behind the scene, explaining the difference between virtual service, destination roles, and so on. We are not speaking about observability. The observability part of Istio, still managed by Mixer, is completely, fully understandable using Grafana, using Jaeger, and using Kiana.
Let's suppose we screw up and we want rollback. We just go back to version 1. All this stuff that I'm doing with the command line will be done by a CI server, of course. Okay. Now we can do the canary deployment. So as you can see here, we will split. We defined two subsets, and now we'll route 80% of the traffic to the old version, 20% to the new version. Let's just deploy the number 6. It's going to be a bit tricky. We have to click many times to kind of see the pattern.
Also for compliance, for the percentage and the weight are the same amount of the same value, so 0 to so you're not getting confused. We have to remember already a bunch of stuffs on Kubernetes and so on, plus Istio, and then it's coming. Has come already something else on Istio. So
White.
So can you please open again the page? So we should have 80% on the white and 20% on the green, right?
So it's more. It looks more on the whites.
So on 10 we should have 8. Then it's 2. So who is green right now? 1, 2. Someone more. Well, the 20% is not achieved. Nice. We are starting.
We need large numbers. Okay, this was the canary, splitting traffic just 80-20. And then there's the last part, so we can split according to the browser. So
that is still canary. So who has an iPhone, please open Safari.
So what can we can have, for example, Chrome. So in this here, Chrome.
No, there is no
we'll
Safari.
Get the version 2.
It's more complicated. So who has an iPhone should get the.
I think it's Safari, right?
Yes, it should be. No, I don't remember.
Let's use Safari here.
So Safari should be green, right?
Yeah, and I should get white.
Okay.
So let's double check. Safari should get the green.
It's white, right?
No.
I have to deploy.
You have to deploy it still.
1 second.
Just 1 second.
Number 7.
Now before was 80-20, version 1 and version 2, so the 20%.
Hopefully, to the regex. You know?
Should land on green. Now after a couple of seconds, you should get. No, because it's not Safari. That's fine.
1 second.
Try with Safari.
Yeah, it's Safari.
No, try with Safari browser. Let's see what's happening.
Green.
So actually, it's not Safari.
At least not Safari document.
Yes.
So let's keep it to Chrome.
Yeah. Is because that's the user agent for Safari is not actually Safari. It should be another keyword, and then we can define another regex to define Windows or Microsoft Edge or Linux or whatever. So you can play around it.
Chrome should get the green.
Now, who is using Safari should get the white.
Yes. And Safari should get the white. So we can split traffic and whatever. I mean, you can even come up with some more intelligent split.
And this is letting our beloved front-end guys to make extensive tests. Also on production. We can also limit user agent headers, or you can play around with destination roles, with virtual services as you wish. And what we learned also is that why not to test in production?
Yeah.
What's the difference between production and stage? It should be the same, right? So we can play easily on production and limit our tests to us as developers or DevOps guys or front-end developers or whatever on a specific part of production, on a specific cluster, whatever, because Istio is able to manage multi-clustering. Even, for example, even, for example, I don't know if you know, Google Cloud now is launching a beta service that is sharing the Google Kubernetes engine between cloud and bare metal, so data center of the customer. And this rely on gRPC, and guess what? So that's why it's so cool, let's say, this part of Istio and this kind of things that you can play around, you can communicate. So you can test in production, and you can have part of production on bare metal, on data center, and part of production on cloud, and you can test, and you can play, you can route differently, and so on and so forth.
I think there is a match. Switzerland against France.
Ah, okay,
Yeah.
great.
So now, yeah, do you want to switch to your laptop?
No,
or-
it's okay. It's okay. I will use it. It is working, so we cannot introduce any more kind of testing. Yes.
So canary deployment is very nice, but I guess I'd like my client to be consistently routed to the same, like this 10% or 20 reroute to the same server, or like have sticky sessions of some kind. Is it possible with this?
Yes, you can limit. In this case, we were testing, but is a bit complicated. You can test based on the user that is logged in. Actually, analyzing the request itself. So if you find a specific header, if I remember, you can split. So if I'm logged, I get the green. If you're logged, you get the white. You can split this, and for this you can have pilot customers in order to be testing. And this is not canary. Should be considered A/B testing.
Yeah.
That is pretty different than canary. So you can play around as you wish.
Yeah, exactly. There's a bunch of stuff in the documentation.
I had one question was exactly sticky. Another one was, is it always round robin? Or is it also
No.
weighted or something?
Default is round robin. Okay, now I don't remember other policies, but there are implemented 2 or 3 different policies, load balancing policies, in the Istio Ingress Gateway, or better, in the Istio repository, sorry. And but I don't remember which one. You should go to the documentation to have a look, and you can change the default one, like the Kubernetes service, is round robin. Then you can play around it and use it. Actually, you can still route also based on the response time of each single service. So if the service is performing bad, the whole traffic will be redirected to another one. You can still do like this. But we are running out of time and too complicated to do like this. But you can play as you wish. And they are constantly deploying new features and so on. And they are planning to introduce some 2 or 3 other kind of load balancing boxes.
And then, so no question, no right answer, but I just want to know, can this be used for testing feature toggles?
Testing features?
Feature toggles. It's a different, maybe you pass something in the header, deploy in production, feature toggles. So
Yeah.
the new features are in production.
I suppose so.
You can use also custom headers, for example, just employees.
Yes.
So it's really super customizable.
As you have seen here, there's the possibility to define. Yes.
You define whatever. I mean, there are a bunch of.
Yes. As you wish, you can play. Yeah, there are some kind of limitations, but in my opinion, there is still a lot of space. I mean, how many of us is using just 50% of this feature, apart from Istio?
So basically, the feature toggling would happen through the usage of different pods, right? So feature toggling would be an option if I filter out user group A, and basically just say I want to test one additional feature with them. I would just use another pod to root them basically on that.
You can decide between pod and service.
Okay.
Because here we are speaking about virtual service. So you are pointing to a Kubernetes service. On the other one, this is the destination rule, you are pointing to the same service, same Kubernetes service, but on another pod. that is still in the same group, but is used by Istio for specific things. So it's not part of the real round robin of the service. It's part of the round robin just under specific conditions. In this case, for example. So you can play around. This is managed by proxies and mixer.
So my question is more in general. So if I understand that correctly, all the traffic is routed always through the sidecars, which introduces an additional latency because I have to go through the HTTP stack and down and up and all the way down to IP.
Should not go farther because the proxy is L4. L4 and should not go farther, so the latency is limited. The latency is mostly not because going through envoy, just because the proxy is communicated with the mixer to check policies. This communication, even considering cache, is introducing latency.
Why is that? It's not once deployed and then just followed? I mean, I would assume that if once I via the control plane define a rule and deploy that rule, that my proxy should not, or the sidecar should not be required to go back to the control plane for each request.
They are working on that, and they will release Mixer version 2. No idea when, but they are working on that, and there is written also in the Mixer documentation, because this is introducing more latency. So they are going to a version that is not that the proxy is not communicating anymore to the Mixer. For policies.
Okay, so that only once deployed the rules that it goes directly to the endpoint. But still,
this is not described, so I don't know honestly what about technical details.
Because what I was reading is that it actually introduces latencies up to 10-50 milliseconds per request. Sounds to me quite
under load. They claim to be 8 milliseconds when you have 1,000 requests per second.
Depends, of course, on what chat you applications.
Depends. If you are, there is always a threshold. If you are accepting that the development time is reduced by, let's say, 50%, because we have to implement circuit breaking, load balancing, client load balancing, retries.
I get the concept.
And so this is we have to. As always, the blanket is...
it's always a trade-off. And is Istio supporting also gRPC calls?
Istio is supporting HTTP 1, 2, gRPC, TCP, whatever you like.
Even TCP?
Even TCP, yes. So you can run on gRPC or on TCP, the communication between proxies. Yes. And this is completely transparent to services. So you don't have to rely on gRPC in your service.
Yeah, sure. I mean, I would expect that. I was reading also about a specialized service company that found a way to, let's say, uses a different concept to even reduce the latency down to less than a millisecond.
Interesting.
They are using, this is more knowledge sharing question, so they are using, there was a paper, and that paper showed how you could basically create virtual sockets directly on the virtual machine which runs two containers, so that you don't have to go through a key step from the envoy towards the pod that runs the service, but that you can directly go through socket-to-socket communication. But
I suppose
there's I think in the documentation is even an article about
this is really cool. I suppose that security guys will be not really happy about this because socket security and so on. This is also the point of Istio. Everything is now we are using.
Transparent. You don't see it from Istio. Doesn't see it. It's just.
No, you're sure. What about communication? Hacking
from Istio you don't see it. It's transparent from Istio, but it happens a layer below.
Mm-hmm. Sure. So it depends.
Of course, for security reasons.
Let's see. But this is a really good point. And this everybody is concerned about the latency caused by Istio. But now we are not using TLS, mutual TLS between services. But this is not introducing latency at all. no latency about that. The latency is based on your destination rules, virtual services, your policies. So as more policies you have, as much latency you hit.
Because these policies get checked every time.
There is cache. There is a really strong cache on proxy and on mixer.
Okay.
But still, sometimes some communication should happen between
But still
lines.
potential for improvement.
They are working on that because they were complaining, and they are still improving because at the beginning was 20% granted the latency on top of the request. And another point, just to complete your question, is telemetry is not impacting on latency. Telemetry is happening just like in the code is happening kind of another thread. Envoy is communicating telemetry, best effort, later.
Easy.
Easy, yes.
Let's try to show the
Yeah, sure.
last part.
So, just give me a second. So now we figure out that there is Istio is very cool, it's nice, and so on and so forth. But what's happening? I mean, we should analyze what's happening really based on the principle of observability. Otherwise, our system doesn't exist, right? So we are having a look. Now we can have a look to the.
So you are allowed to copy?
Yes, I'm the boss.
Is the big
But as you see, as you can see, it's not allowed.
Knowledge to DPS.
No.